Welcome to qnawire.
This question says, the accompanying graph shows titration curve for two monoprotic acid. So A, which curve is that of a strong acid? So if we look at the curves, it looks like this. One is blue and the other one is red. So the red one looks like this. And then the blue one kind of look like this. This is not a perfect diagram, but it's as best as it could be. And this is pH on the y-axis and volume of NaOH on the x-axis. It increases this direction. So, which curve is that of a strong acid? So we have A and B. So initially, if we started before we add sodium hydroxide, it looks like this at 0. That means the pH here is higher than the pH here. It's lower than the pH here. So at lower pH, you have a higher concentration of the acid, right? So B has to be the strong acid. Okay. So B says, what is the approximate pH at equivalence point of each titration? If we look on the original picture, we need that here. So for A at equivalence point, for curve A at equivalence point, pH is pH at equivalence point is around 8. For curve B, the pH at equivalence point is around 7. Okay, so that's that. Then C said 40.0 milliliters of each acid was titrated with 0.1 molar base. So 40 ml acid plus 0.1 molar base. Which acid is more concentrated? Well, so to be able to provide an answer to that, we have to look at the curve again. All right. So we'll look at where we started from. So for A, let's see, in the original graph, the equivalence point for the B is almost around 40. This is like 40, and the equivalence point for the A is around is around 30. Okay. That means straight away we know from this graph that for B, we're likely to have almost the same concentration with base. So concentration of B is likely to be equal to that of base, right? Which is 0.100 molar. And for A, we reach the equivalence point around 30 mil of the base. That means that A is less concentrated than B. So that means B is more concentrated. And then they said we should estimate the pKa of the weak acid. So the weak acid is A, and the pKa would be around 8, because at equivalence points, pH is equals to pKa. So the equivalence point is around 8. That means the pKa is almost equals to 8.